What's good, lads and ladies? Ryan coming at you from the Natural Remedies. In this one, I wanted to talk to y'all about how plants signal to other organisms what's going on, right? In lieu of the video that I put up yesterday talking about my deadlights having PM, how some plants have all the problems and how some plants have none of the problems, right? That's contingent upon the hormones, the smells, essentially, the signals that that plant is putting out. And for example, last year when I had some outdoor plants, my bee leaf had no problems, but the grape patch had like all the problems. And the Agent Orange Wookie Foot had some problems. The Disco Cruiser had no problems. And so it's like some have problems, some have no problems. Some have more problems or all the problems, and some only have a couple and they're easy to deal with, right? IMO, in my opinion, it's worthwhile to do a pheno hunt and find out what plants are attractants or what plants are repellents, what plants have resistance or what plants don't have resistance. And to me, it's only worthwhile to breed plants that are naturally repellents or deterrents, and also have natural resistance, basically, right? So what I mean by that is if one plant every single cycle has fungus gnats or springtails or thrips or something like that, it's not really worth breeding with, right? And yeah, through hybrid or outcrossing, generating hybrid vigor, one can remove essentially that attractive quality to those pests from that plant, right? One could remove it through outcrossing again. But in doing so, you have one plant that doesn't have resistance going on to one plant that does have resistance. Some of the plants won't have resistance still. And so that's why, to me, it's worthwhile to do a pheno hunt or to do predicative testing and find out, hey, this plant has resistance and also repels pests. So that's a plant that's really worth breeding with, right? Then does it check out morphologically, aesthetically, etc., right? But basically, some plants, again, attract pests and all the problems, whereas some repel pests and all the problems, kind of a thing. And another fun thing too about hormones and scents and signals and stuff like that, let's say one plant is getting attacked. Let's say there's another plant just downwind of that plant, right? As that plant's getting attacked and wind passes over that plant, it's going to send the signals to this other plant. And so this plant currently is in a stress state. It's releasing stress state signals, right? This plant's going to pick up on that and fortify itself, which is really, really, really cool. One reason why you should have plants slightly touching or being around each other in a high wind environment, an environment with a lot of airflow, right? It moves all of these signals around. And so if one plant has problems, another plant will fortify itself before it gets problems, and then it doesn't end up with any problems at all, which I think is really effing cool. And so plants can communicate. They can tell each other what's going on, whether or not they're happy or not. And if you have plants in the same bed, right, the same mass of soil, right, the same bit of earth, then they'll communicate through their roots too. And so let's say a fun example is through, I can't remember the scientific name, but like cabbage, broccoli, cauliflower, had to burp real quick, and kale. They're all in the same family, right? And so if you were to plant them by each other, they're all compatible, they're all similar, they're all from the same family, right? And if their roots are touching, they will actually say like, hey, are you down on newts? Here are some newts. So they'll transport nutrients to each other. This is evident through mycorrhizal fields, that's what I'm going to call it right now, but basically through like the web of mycorrhizal fungus. You have, ectomycorrhizal fungus, which interacts primarily with fir trees or trees in general, things that stick around for a long time, kind of a thing. That's fungus in general, but in the particular instance of trees, let's talk about the redwood forest, right? Those trees have been around for a long, long time, so they have a vast fungal network or a fungal field. And these networks, right, one plant here, 1,000 miles away from this other plant here, can say, hey, I need some nutrients, and then it gets sent. That's really cool that plants have the capacity to communicate via other organisms that they form associations with directly with each other via their roots as well as through their leaves. Above ground, below ground, all around, you know? So that's basically all that I wanted to say on plants, that they do produce signals, that other plants pick up on those signals, that pests and stuff can pick up on those signals. And finally, the main point is that if one is doing a breeding project, it is so worthwhile to find out what plants do what. So far in my deadlight stock, one plant had PM, 2 of the 5 plants had springtails. And so that to me is stock that's not worth breeding with at all, because most of the plants out of that stock attracted some kind of an issue. And so boom, it's not worth breeding with at all. It's not worth running again because I don't want plants by that plant to get PM or springtails or this or that. And so it's worthwhile as just a hobbyist cultivator too to pay attention to what different phenos bring to the growing table. That's all I'd like to say though. Stay high, happy, and healthy, Canna fam. Till next time, peace.